So we are going to use the quadratic formula to sketch a quadratic. As I have mentioned, the first thing you are going to do is you are going to do the discriminant. Gentlemen, grow up. Can't believe I'm having to put that on YouTube for everyone to hear. But anyway, all right. What we're going to do is we are going to work out whether we have roots that are real or unreal. So we're going to do the discriminant first. So let's have a look. What we're going to do first is tell me about this first one. Question A.
It's a sad face.
Sad face. Thank you, mate. Concave down. Excellent. What else can you tell me?
The y-intercept is 1.
The y-intercept is 1.
Yeah. The y-intercept is indeed 1. That is indeed 1. Because you see how it's like
Cool.
the one that doesn't have any x is the y-intercept.
All right. What else can you tell me? From what we've just been looking at, the boxes we just looked at, what are the next bits of information I need? Nah, we'll get them in a sec. But we're going to use the quadratic formula for that.
You need the discriminant. Oh, you need what A, B, and C.
To find the discriminant, we need to know what A, B, and C are. Because what is the discriminant again?
Square root of b squared minus 4.
B squared minus 4AC. So we need B, we need A, and we need C. So what's A? B. C. Awesome. So we now have the things we need to do it. So what is the first thing we're going to find? We can do the discriminant, but what's the other thing we need? Do we have a formula for the axis of symmetry?
Yes.
What is it?
X equals minus b on 2a.
Minus 6 on minus 2, which would give me 3. That's his axis of symmetry. So that gives me the x value for it. And then I'll go when x equals 3, we get y equals minus 3 squared plus 6 times 3 plus 1 gives me what?
Wait a minute.
10. So my axis of symmetry is 310.
Wow, isn't that wrong?
Probably.
Thanks.
So, because you probably did minus 3 squared and got 9. Whereas it's minus
Minus 3?
3 squared.
Wait, what does 3? Putting the axis of symmetry into the. Where does 3 equation do? Would that give us the
Yeah, so my axis of symmetry is at 3. So I chuck that back in and it gives me my vertex.
When x equals. Oh, so I got to cross all this.
All right. So we now have our axis of symmetry. We have our vertex. We also know that it's concave down. We have our y-intercept.
Oh, wait, I was still right. I just did a bit you haven't done yet, I think. Don't worry about it.
What's the next thing we're going to do? We need to find the x-intercept, and we're using the quadratic formula. So what do we find first? Discriminant equals
I just crossed all of that.
b squared minus 4ac, which in this case will give us 6 squared minus 4 times minus 1 times 1. Everyone happy with that?
Yeah.
Which gives us what?
36.
Yep, 6 squared is 36. Plus 4. 40. I shouldn't have to do multiple steps when it's just arithmetic. I don't want to do the 6 squared first and then do the minus 1 times 4. You guys are in year 11. You should be able to do arithmetic. So 6 squared minus 4 times minus 1 times 1 will give you 40. Yeah? What does that tell me?
We have 2 numbers.
All right. Now, what do we got? Sorry? 2 real roots. So now we're going to use the quadratic formula. So what do we got? So we've got x equals minus b plus or minus square root of 40 over 2 times a, which is minus 2. Oh, I shouldn't have done minus b. I should have done minus 6, shouldn't I? That's it. Now, can you see how not writing the whole lengthy thing, we're just chucking in the delta bit. We're just chucking in the discriminant. We've already calculated the discriminant, so let's just chuck that in. Now, I've written it as a plus minus because I've got two of them and I don't need to do anything else. Now, have a look at our discriminant. We've got root 40. Is there anything we can do with that to make our lives much more easier? Pull the 4 out, which will give us what? Oops. So it'll give us root 4 times 10, which we could pull the root 4 out, which gives us 2 root 10. Okay? You can actually do that up at this part. Recognize that it's made up of a square number and go, well, that's 4 times 10, because that's going to help you. Yeah. All right? So what are my 2 roots? I have minus 6 plus 2 root 10 over minus 2, or I have minus 6 minus 2 root 10 over minus 2. So I've got 3 plus 2 root 10 or 3 minus 2 root 10. Oh, no, not 2 root 10 because I should have divided by 2 as well. Root. I was dividing everything by 2. Then you could chuck that into a calculator to get decimal representation of it, and you'd be fine. All right, so now you've got all your intercepts. I'm not going to bother graphing it. You guys can graph. Yeah. Everyone okay with that? All right. Let's do B. What's the concave, up or down? What's the y-intercept? 4? Oh, there was a lot of... Y-intercept equals 4. So what's my A?
3.
B? C? Cool. What's my symmetry? My axis of symmetry?
Minus 3 over 2a, which is minus 6 over 6, which is minus 1.
Shouldn't it be 6 over, because it's, wait, never mind. No, yeah, it should be positive 6 over.
Yeah, so.
Yeah, so it's minus 6, which will give you positive 6.
Yeah.
So axis of symmetry is 1, which means your vertex. Yep, sub it back in. So it's when x equals 1.
So yeah, what? 3 times 1 plus 6 plus 4.
7?
It's not 7. 3 times 1 squared minus 6 times 1 plus 4 equals 1.
Wait, it equals 1.
Yep. Because 3 times 1 squared is 3, minus 6 is minus 3, minus 3 plus 4 is 1. So we now have that. So all we need to do now is find our discriminant. Our discriminant is what? B squared. So that's minus 6 squared minus 4 times 3 times 4. What's that give you? Gives you negative 12.
Wait, minus 6 squared is negative 12.
Nope, negative 6 squared is 36.
Oh, use the all ones, yeah.
I will not do the arithmetic for you.
Okay, so
So I get no real zeros.
that thing.
But what that tells you is you've already got the vertex. You've already got the y-intercept. So you know this one is going to look like that, whereas this one was going to look, oh, that's terrible, like that. Cool. But you guys can do the graphing.
Oh, of course.
But once you've done that, now we're not using the quadratic formula because we know there's no real roots. There's no